Hello and good day to all of you. So in this video lecture, we are going to learn about the seismic wave or any type of wave which deal with the science. So starting with the waves, so let's look at what is a wave. So if you look at the definition, so the wave is a pattern in which some type of energy such as sound, light, heat, or any type of energy are spread or carried out. So this is one of the definition which has been taken from the Cambridge Dictionary. And also a wave is disturbance or oscillation of a physical quantity that travel through matter or space accompanied by the transfer of the energy. So we can look at these figures. So let's say when we drop a stone of into the calm water, so you can see when the energy produced at this point. So the energy propagate with the time. Let's say if you have this or the second stone in the water, so you have traveling waves on both directions. So it can go up to here and up to here. So you mean the energy is propagating. So only the water is not propagating, but the energy which is produced because of hitting this part of the water from the stone, it is propagating. So these type of energies produce in the ocean, so it can become up to these type of waves, because when there is a big movement in the water on the ocean, then you can see the energy propagate to the seashore. So the example of some of the waves are the sound waves, like in that when I'm talking to you, so there is a variation in the pressure in the air. So variation of the pressure in the air. So let's say when we talk each other, so the words are explained based on the pressure of a different type of words. And also we have the radio waves, variation in the EM, electromagnetic intensity, the water waves, variation in the water surface, seismic waves, so the variation in the elastic deformation in the rock. You have to note it down that the medium does not travel along with the waves, but only the energy travels. So the mediums, I mean, the water is not moving. Water is going up and down. So the energy is actually traveling with this type of waves. And also like some waves, which is like electromagnetic waves, do not even need a medium to propagate. It can travel without any mediums. So there are different type of waves. So initially we have divided into two. So the types, which is surface waves and also the body waves. Further in the body waves, we have two types, P waves and S waves. And in surface waves, we have love waves and the Rayleigh waves. So the example is given based on the earth. So let's say the sound waves when there is an earthquake or the artificial source here. So when we propagate the energy at this point, so there is two type of waves propagate. One goes into the body, one travel along the surface. So the waves which travel to the surface is part of the surface wave. In that we have two categories. We will go deeper down into these definition. But in the body waves, so which travels into the body, let's say it goes into the crust, mantle, and the deeper down into the subsurface or any part of the energy. So in that also we have two type of P waves and S waves. So further we will look at the definition or the understanding of the P waves and S waves. So let's start with the body waves first. So body waves actually travel through the interior of the earth, as I mentioned. So they follow the ray path bent by the varying in density and the modulus, the stiffness of the earth interiors. So the body waves are further classified into P and S waves. So first of all, let's look at the P waves. So the P means the primary waves, as they are the fastest arrival in the receivers. I mean, obviously when we send the waves, so we have to travel back on the surface. So these are the waves which reach faster or the first arrival into the receiver. So they are also called the longitudinal or the compressional waves because the particle motion is parallel to the wave propagation. And the ground is alternately compress and dilate in the direction of the wave propagation. And these waves can travel through any type of material, such as liquid, solid, or any type of materials. And the P waves has the following velocity in different mediums. So in the air, the P waves velocity is 330 meter per second, water 1450, granite 5000 meter per second. And also, if you look at the when generated by an earthquakes, so they are less destructive than the PS waves because the surface waves that follow them due to their similar amplitude, smaller amplitude. When these type of waves are generated by the earthquakes, so they are less destructive than the S waves because of their nature of the propagation that we are going to discuss in next slide. So let's look at the animation. So in that, actually, we are referring to the particle motion. So let's say this is a particle in the subsurface and the wave propagate like this direction. So you can see the wave propagation direction is toward this one and the particle motion is also left and right. So it's mean that's why it is called the particle motion is parallel to the wave propagation. So the second type of wave is S waves. So S mean the secondary waves. So as they arrive after the P waves. So they are also called the transverse or the shear waves as the particle motion is perpendicular to the wave propagation. So over here in the animation you can see, so the direction of wave propagation is same as before, but you see the particle move up and down. So it means this is the direction of the wave propagation, but the particle moves up and down. So it's mean perpendicular motion of the particles. So the ground is displaced perpendicular to the direction of the wave propagation. In the case of horizontally polarized S waves, the ground moves alternatively to one side and then the other side. Like this here you can see one side and the other side. So the another property of this wave is that it can travel through solid, but when it comes to the liquid and gases, it does not travel. And the velocity of these waves is 60% of the P waves. I mean, it's a smaller velocity than the P wave, 60% smaller the velocity. And when it is produced during the earthquake, so they are more destructive because of the. Now we move to the surface wave. So in surface wave, we remember from the previous slide, so we have divided into Rayleigh waves and Love wave. So Rayleigh waves, they travel only under the ground or the earth's surface. You can see here, and they are in the form of ripples, similar to the surface waves. The Rayleigh waves are also called the ground roll in the seismic exploration data, and their speed is about 70% of the S waves. And their existence was predicted by the John William Sturt Lord Rayleigh in 1885. So that's why, based on this guy, we name it as a Rayleigh wave. So over here, if you focus in this animation, so over here you can see this is a particle. So the motion is like this one. So only the upper part of this body is moving, but the lower part of this body is not moving because this is a surface wave. You can again observe. So the wave propagation is this direction, and you see it's like the parallel particle motion is retrograde. So the last type of waves, which is the Love waves, they travel only under this Earth's surface. They cause horizontal shearing of the ground, and their speed is about 90% of the S waves, slightly faster than the Rayleigh waves. So it was named after A.E.H. Love. He was the British mathematician who created their mathematical model in 1911. So the Love wave propagate analogous to this movement of the snake or the shaken rope as shown below. So over here you can observe in this animation. So this is a particle and you can observe the motions. And the first thing you can observe, the energy in this wave propagation is at the ground level, but in the deeper part, the energy is not much. In the particle motion, you can see it's left and right. I mean, it's like a snack or when we shake the rope, we hold the rope from one side and we shake it left and right, so you can see the motion of this one is like that. So that is actually the motion of this Love waves. So in seismic exploration, normally we are using the P waves, S waves, and the Rayleigh waves, which is the ground rolls, is mostly removed. And So what are the use of these seismic waves? So the P waves are commonly used in oil and gas exploration, and special three component like 3C, PSHSV surveys also carried out for rock physics analysis and also the reservoir analysis. And P and S waves are used to determine the engineering property of the ground. And the Earth liquid cores was also discovered due to the fact that the shear waves cannot pass through liquid, as demonstrated by the Richard Dixon Odham. And what are the key messages to take away from this part of the lecture? So, because of their wave movement, the P waves travel through any kind of materials, whether it is a solid, liquid, or gas. On the other hand, the S waves only can pass through the solid and are stopped by the liquid or the gases. And the love waves do not propagate through the water, can affect the surface water only insofar as the side of the lake and ocean way pushing water sideway like the side of the vibrating tank. While the Rayleigh waves, because of their vertical component of their motion, can affect the bodies of the water such as lake. So from the first key message, what we can get if we have both surveys like P wave and S wave survey. So from that difference, we can find out any type of liquid and gases, because if we have both survey, so we can judge where is our liquid or the gas start in seismic exploration. And also this was is used for the near surface studies. Okay, with that's all. Thank you so much. I hope you have learned about the waves and their types. And the main thing is we have to focus on the application of the waves. It's like P and S waves, which is mostly used for seismic exploration. So when we are going to do the reservoir analysis, let's say hydrocarbon exploration, we want to look at the oil and gas. So we do both survey P and S waves, and we compare our data like where our S wave is stopped. So that is indication of oil and gas. Thank you so much. Have a good day.